Welcome back. You ever look at a vending machine and wonder what's actually going on inside, physics-wise? Well, today we're going to do just that. We're going to take one single question from a GCSE physics paper and pull it apart, piece by piece, to show you how to lock in every single one of those marks.
All right, so here's the plan. We'll set the scene with the vending machine problem, then we'll just walk through each part of the question. We'll start with some simple recall stuff, then a slightly trickier bit, all the way up to a big 5-mark calculation. And at the end, we'll pull out some key takeaways for your exam technique.
So let's get into it. Question 5 is our target, and it covers everything from how the machine gets its power to the clever way it figures out what coin you've just put in.
Okay, so here's the setup we're given. A student pops a coin into a vending machine. Seems pretty ordinary, right? But this simple picture is the starting point for all the physics we're about to dig into.
All right, let's tackle the first part, 5.1. This is a total classic from the exam board. It's one of those questions they throw in right at the start just to see if you've memorized the absolute basics.
So, it's a 2-marker, and it's asking for 2 key numbers about the mains electricity supply here in the UK. You just have to know them. No tricks, no calculations, just straight up memory.
And here they are. For the frequency, you need to write 50 hertz, that's 1 mark, and for the potential difference, it's 230 volts, that's your second mark. Boom. 2 easy marks in the bag, as long as you've done your homework.
Okay, next up. Ever wondered how a machine can tell the difference between a 50p coin and a 10p coin? It doesn't have eyes, right? Well, this next part of the question gets into it. It's all about measuring resistance.
Now, we're on to a calculation, and this one's worth 4 marks. So you know what that means. We have to show every single step of our working. It's absolutely key. Let's go through it together.
So where do those 4 marks come from? Well, you've got to tick 4 boxes. First, you get a mark just for converting milliwatts to watts. Easy mark, don't forget it. Second, you need to pick the right equation, that's P equals I squared R, and substitute the values in. Third mark is for rearranging that equation to get R by itself. And finally, the 4th mark is for getting that final answer, 0.60 ohms. Simple as that.
Okay, now for a quick 1 marker. This is more of a thinking question. So why would a dirty coin get rejected by the machine? What's the physics behind that?
What's really interesting here is that the mark scheme gives you a few different ways to be right. You don't need one specific magic sentence. The core idea is that dirt gets in the way of the electrical connection. So as long as you say something like the dirt changes the resistance or it stops the current flowing, you're going to get that mark.
All right, we're changing gears a little bit now. The question moves on to a totally different part of the vending machine, the circuit that keeps the food inside cool by monitoring the temperature. So take a look at the circuit diagram we're given. You can see we've got a 12-volt supply, and it's connected in series to a 400-ohm resistor. But wait a second. See that empty box? I have a feeling the next question is going to ask us what's supposed to be in there.
And there it is. For 1 mark, all you have to do is draw the proper circuit symbol for a thermistor in that box. Another one that's just pure memory.
And here's what it should look like. Now, be careful. You've got the standard rectangle for a resistor, that's fine. But the bit that makes it a thermistor is that diagonal line with the little flat bar at the end. It kind of looks like a hockey stick. That's the part that really matters.
Okay, here we go. This is the big one, the final part of the question, and it's a whopping 5 marks. This is where you have to bring it all together. You need to read a graph, you need to understand the circuit, and you need to do a calculation with a few steps.
So what's the actual task? We need to figure out the potential difference, but only across the thermistor when the temperature is exactly 20 degrees Celsius. And to do that, we're going to have to use both the circuit diagram we just looked at and a graph.
Step 1, in the first mark, comes from the graph. You find 20 degrees on the bottom axis, you go up to the line, and then you read across to the side. And what does it say? Right there. The resistance is 80 ohms.
So our key piece of information is 80 ohms. That's what we need to get started on the rest of the problem. Now, what's really cool is that there are actually 2 different ways to solve this and get full marks. Let's walk through both of them.
The first way to do it is what I call the current method. First, you figure out the total resistance in the whole circuit. Just add the 400 and the 80 together. Then you use Ohm's law to find the total current flowing out of the battery. Now, because this is a series circuit, that same current has to go through the thermistor too. So you just use Ohm's law one last time, just for the thermistor, and you've got your voltage.
Okay, method 2 is the ratio method. This is a bit of a clever shortcut if you remember the potential divider rule.
Basically, the total voltage from the battery gets shared out between the components, and it shares it out in the same proportion as their resistance. So the thermistor's share of the voltage is just its resistance, 80, over the total resistance, 480. That fraction, which is 1/6, is the fraction of the total 12 volts that it gets.
And look at that. Both methods get you to the exact same answer, 2.0 volts. That's how you bag all 5 marks. It's a perfect example of how in physics, there's often more than one way to get to the right answer.
Okay, so we've pulled that whole question apart. What can we take away from this that's actually going to help you in an exam? Let's just quickly recap the skills we had to use.
I mean, just think about it. In that one single question, you had to remember facts, convert units, pick and rearrange a formula, draw a circuit symbol, read a graph, and then put it all together in a big problem. The real key to doing well isn't just being good at one of those things, it's being solid on all of them.
So, I want you to ask yourself, which bit of that did you find the hardest? Was it remembering the 50 Hertz and 230 volts? Was it the unit conversion from milliwatts? Maybe reading the graph? Whatever it was, that's the thing you should probably focus on in your revision next. That's all for this one. See you next time.